Well, hello there, everybody. Hope you guys are all doing well. Hey, what we're going to do is a series of 5 short videos where we're going to take you through a crash course in trigonometry from the very, very basics up to the unit circle, how the unit circle works, why it's useful, and some shortcuts along the way. So by the time you're done with all this, you should be rock solid, ready to go, and ready to move on with more advanced trigonometry. Let's get to it. Here's part 1. All right, so here's the deal. What we're going to be talking about is why trigonometry works. Thing is, if you have a triangle, and let's say they have angles A, B, and C, it doesn't really matter how big or small that triangle is. If angle A in the little triangle is the same as angle B in the big triangle, then those sides are going to be proportional. See, if all the angles are the same as each other in the two triangles, then those two triangles are called similar triangles and their sides are proportional. So the trig values are going to be the same no matter what. It doesn't matter how big or small that triangle is. The sine of 50 degrees is a sine of 50 degrees. It doesn't matter if the triangle is, say 5 centimeters long or 2.5 centimeters long or 70,000 miles. It doesn't even matter. The trig values are the same no matter what. So what I'm doing here is I drew a 50 degree, 40 degree, 90 right triangle with a side length of 5 centimeters. And now I'm drawing one with a side length of 2.5. Now, it's pretty close to the same, but the width of the pencil makes it off a little. But when I do the sine of each of these, I get about 0.75. And the actual sine of 50 degrees is, 0.766. So it's really, really close. Close enough that I think you get the idea. Here's the deal. No matter how small that triangle is or how big that is, the values are, the sine and cosine values and tangent values, they are exactly the same. It doesn't even matter. So we can take a triangle that's small enough that we can physically measure it. And we can apply those relationships, those sides, the opposite over the hypotenuse of that right triangle is going to be the same exact ratio if that triangle is something so large we can't measure it directly. But if we can measure the angle, then we know. And so that's what makes trig work. That's what makes it valuable for us today and useful. Anyway, that's part 1. Let's get on to part 2, shall we?